the next section that we look at, there were a couple of strange circuit devices that we look at. So the first circuit device was an LDR. So, oops, right. LDR, so this section, LDRs and thermistors. Okay, now LDR, I'll stick it in yellow because it's something to do with light. Thermistors, I'll put it in orange because it's something to do with heat. So LDRs, LDR, as we said before, stands for light dependent resistor, but it also stands for light decreases resistance. Now thermistors, so the symbol for an LDR, just to remind you, is a diode. Sorry, it's a resistor with some light that's coming towards it like that. And it's in this circle generally. Sometimes it isn't, but most of the time it is. Thermistor is just a regular resistor with this strange kind of tick on it like that. Now, as well as remembering that light decreases resistance, a good way of remembering what a thermistor does is to remember what an LDR is. So LDR, light decreases resistance. Thermistor, heat decreases resistance. Now, the whole point of a thermistor is that it's different to a regular wire. So think about the regular wire inside that bulb. So when it got hot, the resistance got bigger. Now, a thermistor is special. When it gets hot, its resistance gets less. Okay. Now, the way that it changes, so let's say we put more and more lights in this, and this is the resistance in ohms. It changes and it actually goes down in a bit of a curve like that. They both do. So this is heat that way, and this is resistance in ohms. So that's how it changes. It changes in a curve. So it's kind of like an exponential decay curve, you might say. Okay. Right. Now, sensing circuits. Now, these we can use these in order to make things happen, in order to interact an electric circuit with the external environment, you might say. So let's pick a circuit. Let's pick something to do with a thermistor first of all. So let's just put a thermistor. There we go. In the circuit with a bulb, and let's see what happens. So let's imagine first of all that it's cold, and then imagine what happens if it's hot, because it's going to change the value of this resistance, and that value of this resistance is then going to affect how bright this bulb is going to be. So if that resistance is going to be low, then that means there's going to be more current flowing in the circuit, so that bulb is going to be brighter. If that resistance is going to be high, it means there's going to be less current in the circuit, so that is going to be brighter. Right, I'll say that again just in case I said it the wrong way around. If that resistance is high, then there's going to be less current flowing in the circuit, which means that bulb is going to be dimmer. If the resistance is going to be low, it means there's going to be more current in the circuit, which means that it's going to be brighter. So let's imagine when it's cold. Now, we already know that heat decreases resistance. So heat decreases resistance, so cold increases resistance. And it's a bit of logic. Cold increases the resistance. Now, if the resistance of this one increases, then that means there's less current in the circuit. And if there's less current in the circuit, then that means there's a dimmer bulb. Now, if it's hot, if as in the surroundings are hot, then that resistor gets hot. Heat decreases resistance. So Now, if it decreases resistance, we get more current. And if we get more current, hang on, I didn't mean that. If heat decreases resistance, then that means we get more current, which means a brighter bulb. Okay, now the type of circuits that we use won't generally look like that. They'll look slightly different. And let me do a circuit like this, but I'm going to do it this time for an LDR. So there's our LDR, and just going to put around it a bulb. Now ignore the fact that that's a bulb and it's next to a light dependent resistor. I know it's a bit weird because it'll create light for the light dependent resistor, but we just ignore that for now. So this is a fixed resistor. Now let's imagine you've got 10 volts on that battery. Now if these two resistors are the same size, then that means that we would get 5 volts and 5 volts there going across those two. But as they change, we'll get a different proportion. So let's say that this resistor, this light dependent resistor, becomes very small. Then what that means is that maybe 9 volts goes across there and 1 volt will go across there, which means the bulb isn't very bright. Let's say that we make this very big, this resistor. Then what's going to happen this time is that if this resistor is very big, then that means we might get 9 volts across there, so most of the voltage across there, and only 1 volt across there, because that's very big compared to that. And that's the way the voltage will be split up. Now, if I just go back a little bit, this is what this circuit will look like, and what you will be asked to do is probably explain what this circuit does. And so let's have a look and go through the logical steps. So first of all, we'll say if it's an LDR, so we'll say if it's light, then now we know it's an LDR, so light decreases resistance. So it's the resistance of the LDR decreases. So this becomes smaller. And if the resistance of that decreases, then that becomes a lot smaller, which means the voltage of this becomes smaller, which means that voltage there becomes smaller. Across the bulb, dimmer bulb. Okay, so LDR, light decreases resistance, that resistance becomes smaller, that voltage there becomes smaller. So that's something worth remembering, and if that resistance increases, then that voltage increases, so that means that the bulb will become brighter. Okay, now we can do exactly the same thing very quickly if we wanted to do that with a with a thermistor, and let's do the same with a thermistor. And sorry for the noise, that is my dishwasher. Okay, there's our bulb. Now let's say it's hot. So we've got heat decreases resistance. So that means that the resistance of this one goes down, which means the voltage of that will also go down. Right, so what can we do in order to make it work the other way? Now, the thing we can do to make this work the opposite way is we can move around and swap where we put our bulb. And if we put our bulb across there instead, then if it's hot, heat decreases the resistance of this, which will decrease the voltage that goes across that, which will in turn increase the voltage that goes across that, because the voltage of these two combined must equal the voltage of the battery. Whatever it is. Now, it is quite complicated. I suggest you have a look, page 46 in your revision guide, if you've got a physics revision guide. In the trilogy revision guide, it's slightly different.